In this video, I'm going to talk about some important things about resistors in parallel that will be very important when you try to solve multiple choice questions. These tricks and techniques will become very handy when you try to solve multiple choice questions. So the first one, you are given two resistors that are in parallel. And you need to find the equivalent resistance of these two resistors. So you can use this equation. 1 over R equivalent is equal to 1 over R1 plus 1 over R2. And then if the numerical values are given, you can simply substitute and get the answer, the numerical value. Or else I will simplify this further algebraically, and then I'm going to get this expression. Okay, now I'm going to take the reciprocal to solve for the equivalent resistance, and we'll get R1 times R2 divided by R1 plus R2. Now what does this mean? So this is the equivalent resistance for two resistors. This applies only for two resistors. When two resistors are in parallel, so you can see this circuit here, these two resistors are in parallel. This is called a parallel circuit. Okay, so when they are in parallel, this is how you find the equivalent resistance. So just to get the idea behind this, what you need to do is that if you are given two resistors in parallel, you simply take the product of those two resistors and then divide that by the sum of the two resistors, like this, and then you get the equivalent resistance. So that's how you get it. You understand the process behind this expression. Okay, now let's try to do an example related to this. So we need to find the equivalent resistance when these two resistors are connected in parallel. So 60 ohms and 120 ohms. So how do you do that? Equivalent, you should be able to directly multiply the two values, 60 times 120, then divide by the sum of the two resistors. So 60 plus 120. So then you can simplify this further. 60 times 120, divide this by the denominator would be 180. So you can simplify this further and you will get 40. So the equivalent resistance would be 40 ohms. So that's how you do this. Sometimes you might try this method. You might write 1 over Req equals 1 over 60 plus 1 over 120. You would end up with the same value. If you do the math correctly, you will end up with the same value. But here, if you can memorize this expression, only if there are two resistors in parallel, okay? If you can memorize this expression, then it would be very easy for you to calculate the equivalent resistance. Okay, so that's one thing that I want to explain in terms of with regards to resistors in parallel. Now, another important thing is when there are n number of resistors. Let's say, for example, here you have identical resistors. Each one has a resistance R, and there are n number of resistors. So there are like n number of identical resistors in parallel with one another. So when you see a connection like this, it's parallel. So here previously, if you remember, I drew the circuit diagram like this. Okay, but this is equivalent to drawing the circuit like this. Let's say this is like R1 and R2, I think from our previous example, and here R1 so this is going to be the same one. Okay, so that's why, like, even if you see it like this, you should understand that here what you have is a system of resistors that are in parallel with one another. Now, if you have n identical resistors in parallel, how do you find the equivalent resistance for this system? So that means we need to find what is the equivalent resistance. So here I'm going to use that general expression 1 over R equivalent. I will write 1 over R. I have another 1 over R, so that's the first resistor, second resistor, and like that I will have n number of resistors. So there will be like uppercase N or capital N number of resistors. So that means N multiplied by 1 over R or N over R. That is equal to 1 over R equivalent. So then when I take the reciprocal of this, the equivalent resistance will be R divided by N. So you can see if there are identical resistors, n number of identical resistors in parallel with one another, the way to find the equivalent resistance is take one resistor and divide that by the total number of resistors connected in parallel. So as an example, let's say that you have 10 resistors. Not 10, but let's say I have 5 resistors, each one, and then this system is connected to some sort of a battery, and each one has 10 ohms. The resistance is 10 ohms. How do I find the equivalent resistance for this system? So equivalent resistance, simply use this idea. So one resistor, so you have to identify the first thing, all the resistors are in parallel with one another and all the resistors are identical to one another. So you take the resistance value of one resistor, then divide that by the total number of resistors. So here you have 5 resistors and then your answer would be 2 ohms. So it's that simple. Okay, so this is the second point that I want to explain. The next one is a parallel circuit. When resistors are in parallel, they behave as current dividers. So for example, now here I have R1 resistor and R2 resistors. They are in parallel with one another, and in order to send an electric current across the circuit, what do I need to do? I need to connect this to a EMF source or simply a battery like this. So this longer terminal gives you the positive side and the shorter one gives you the negative side. So let's say that the EMF is E. So EMF is in a way the potential difference or the voltage across the two terminals of the battery. Okay, so when the resistors are connected in parallel, a very important thing happens. That means the voltage across all these resistors would be the same. So if this is V, voltage across the resistor R1, then this value would also be V, the voltage across resistor R2. And that will be equal to the voltage across the battery, which we can call V. But from this one you can see V is nothing but the EMF of the battery. Okay, so this is a very important thing when resistors are connected in parallel. You can have any number of resistors connected in parallel, but the voltage across all those resistors will be the same. So in that sense, you can see this I current comes to this junction, and then it's going to break into two parts, I1 and I2. So I1 will go across R1 and will emerge from here as I1. I2 will go across R2 and it will emerge from this side as I2. And they will converge, they will combine at this point, and then again you'll have I, the current I, and it will pass through the battery again. So all these are I. Now from conservation of charge, you should also know that I is equal to the sum of all these currents, like these currents in the branches. So I equals I1 plus I2. This is another way of saying charge is conserved. So two important things, the current, charge, conservation of charge is obeyed, and over here the voltage across each resistor would be the same, and that is equal to the voltage across the battery or the EMF device. Now let's see how can we divide the current between the two resistors. So I can write down Ohm's law, for example, for resistor 1. So voltage across resistor 1 is V. Ohm's law is equal to current through the resistor times the resistance. So the current through R1 is I1 and the resistance R1. Similarly, for resistor 2, I can write V equals I2 times R2. Now you can see the left hand side is the same, that is the voltage across resistor R1 and voltage across resistor R2. As I told you, for a parallel circuit, they are going to be equal to one another. So then I have R1 times I1 times R1 is equal to I2 times R2. So this is an important relationship. So this is how the currents are divided by the resistor. Or I can write this as a ratio. For example, I can write I1 over I2 is equal to R2 over R1. So that means you can see I1 is proportional to 1 over R1 and I2 is proportional to 1 over R2. So in that sense I can write I1 proportional to I2, and that is equal to 1 over R1 proportional to 1 over R2. So this is another way of writing this expression. So that means if you are given in a parallel circuit, when the resistors are connected in parallel, if you know the values of the resistors, you can figure out the current through each branch. Provided that you know this I current, you can find out I1 and I2 as a ratio of R1 and R2. So this happens if you have two resistors in parallel. Now here you have three resistors in parallel. It's the same thing. You extend that analysis for three resistors in parallel. So again, when you connect this to a battery, what you'll have is the voltage across each resistor would be the same. Here it would be V, here it would be V, here it would be V. And from charge conservation, you can see I is equal to I1 plus I2 plus I3. That is charge conservation. And then for each branch, I can apply Ohm's law, and then I'll get V equals I1 R1, V equals I2 R2, and V equals I3 R3. And then the left hand sides are the same, so I can write I1 R1 equals I2 R2 equals I3 R3. And as a ratio, if I write down this, I can have I1 proportional to I2 proportional to I3, and that is equal to 1 over R1 proportional to 1 over R2 proportional to 1 over R3. Okay, again, this is something important, especially when you try to solve multiple choice questions related to resistors in parallel. This would become very important. Okay, let's do this example problem. So it says A1, A2 and A3 are ideal emitters that are connected as shown. If A3 reads 2 amps, so that means this emitter reads 2 amps, when a potential difference is applied across the two ends, so that means something like this, you apply a potential difference by connecting an EMF source, which we call like a battery, and then there's because of the potential difference, there's a current passing through the circuit, and over here the main current I breaks into 3 parts, and for each of the resistor you have, for example, I1, I2 and I3 passing those through 3 resistors, and from here you'll again see I1 emerging. On this side it will be I2, and on this side it will be I3, and here again you'll find I, and then it will come back and go through the negative terminal of the battery. So something like this. The question tells us that the reading over here is 2 amps. If that's the case, find the values of A1, A2 and A. We already know how to find A because the reading for A, which is I from conservation of charge, we know that's equal to I1 plus I2 plus I3. Okay, so we only need to find I1 and I2 because I3 is given, and then we can find I, or the ammeter reading in ammeter A. But how are we going to find A1 and A2? For that, I'm going to use the previous result that I obtained, the ratio between the currents and the resistors. I told you that when resistors are connected in parallel, the current, there's a current divider. It's a current divider circuit. Parallel connections of resistors are current divider circuits. So in that view, I'm going to, from the previous expression, I can write current I1 proportional to I2 proportional to I3 is equal to 1 over R1 proportional to 1 over R2 proportional to 1 over R3, like that. Now they have given that I3 is equal to 2 amperes. So I can further write this as I1, I2, this is 2 amps equals 1 over R1, which is 20 ohms. So just for now I'm going to simply drop writing down the units. 1 over R2, which is 1 over 5, 1 over R3, which is 1 over 10. So I have these ratios. Now I can find simply I2 by comparing 1 over 5 and 1 over 10. So I have I2 over 2 is equal to 1 over 5 over 1 over 10. So proportionalities are pretty much simply like ratios. So I can do the same thing. So here if you simplify this, you are going to get 10 over 5, which is 2. So I2 is I2 over 2 is equal to 2, and that gives you I2 equals 4 amps. Okay, so the reading here is going to be 4 amps. Now for I1, the current through emitter 1 or resistor 20 ohms, in a similar way I can compare currents I1 and I2 because I know I2 is 4 amps. So I have I1 over I2, which is 4, is equal to 1 over 20 divided by 1 over 5. So this would mean I have basically 1 over 4, and that means I1 is equal to 4 times 1 over 4, which is 1 amps. So the current passing through 20 ohms resistor is 1 amps. And then you can see, in order to find the current through ampere A, I just need to sum up all these current parts. So here I'll have 1 amp, and here I have 4 amps, and over here I'll have 2 amps, resulting in 7 amps. So the current here is 7 amps. So that's how you find the current, the total current across the, so that's the current that passes through the battery, the total current, and the current along these segments or the respective resistors. So that's how you figure this out. Let's try another example problem. If the battery potential difference V is the same for both circuits, determine the current I across the battery in the right hand side circuit. So that means we need to find out this current that goes through the battery, and that current actually at this junction breaks into two currents. Okay, so we are not supposed to find these two currents, we just need to find the current through the battery for the right hand side circuit. So again, you can see these two configurations are two resistors in parallel. The same voltage, you can see at these two ends, the voltage or the potential difference is V. Similarly, at these two ends on the right hand side circuit, again the potential difference, the voltage is V. So I can apply Ohm's law for circuit on the right hand side and the circuit on the left hand side and equate them together because they are at the same voltage difference. So Ohm's law, if you recall, that is V equals potential difference across a device, in this case resistors, is equal to the current times the resistance. Okay, so the voltage is V. I'm looking at the left hand side system. V equals, the current is given as 4.5 amps. Okay, and the equivalent resistance, let me call it R equivalent left hand side. Okay, and then for the right hand side circuit, again from V equals IR, I can write V, potential difference, the voltage is the same for both circuits, is equal to current I through the battery times the equivalent resistance for these two parallel resistors. And let me call that R equivalent times R. Now the left hand side, let me call this equation number 1 and this is equation number 2. The left hand sides of these two equations are the same, equal to one another. So from 1 and 2 I can write 4.5 times R equivalent L for the left hand side equals current I, that is the current through the battery on the right hand side circuit, times R equivalent right. Okay, now I need to simplify this further. So you can see 4.5, and how do I find the equivalent resistance when two resistors are in parallel? I mentioned a very quick method to figure that out. You multiply the two resistors together. So 4 times 2, 8. 8 divided by 6. Okay, and on the other side I get I, equivalent resistors on the right hand side system. So 8 times 4, that is 32, divide that by the sum of the two, 8 plus 4, which is 12. So from here I can solve for I to figure out the current, and then you can see these cancels out. So I have here, I can cancel out the 6 and the 12, so there's a 2, and then 8 times 4 is 32, so I have that, and then I can further divide this by a 2, so the current I is equal to 4.5 divided by 2, which is simply 2.25 amps. And that's how you find the answer for this particular problem. So this can appear as a multiple choice question. So it's a very good it's a very good example where we can simply write down the equivalent resistance when two resistors are in parallel. Just let me remind you how to do that. You simply multiply the two resistors, R1 and R2, divide that product by the sum of R1 and R2, and that's how you get the equivalent resistance when two resistors are in parallel. This only works when two resistors are in parallel, so keep that in mind. Okay, let's try this example problem. The total power dissipation of each of the following circuits, they are given as A, B. So the power dissipation is PA, PB, PC, PD, and PE. Rank PA, PB, PC, PD, and PE in order of increasing total power dissipation. Note, each circuit is connected to the same potential difference V. So that means the battery voltage is the same for all 5 cases. What does that mean? It means that the potential difference between these 2 points for all the circuits will be the same. It will be V. Okay, so the circuits, the potential difference is the same. Now, power dissipation equation can be written like this. If P is power, that is equal to voltage or the potential difference squared divided by the resistance. Here, instead of just one resistance, we have to use equivalent resistance for that given circuit. However, since we know that the voltages are the same, simply we can write power is proportional to 1 over R equivalent. So that means there's an inverse proportionality between power dissipated power in the circuit to the equivalent resistance of the circuit, of a given circuit. If the equivalent resistance is smaller, then the power dissipation is greater. That's what this tells you. So this is one important thing that you will need when you try to find the solution for this particular problem. The second one is the fact that when two resistors or like several resistors are connected in parallel, the equivalent resistance is always less than the smallest resistance in that circuit. So that's the next one, important one. Equivalent resistance that is R equivalent is less than the smallest resistance in the parallel circuit. So this only applies for parallel circuits. Keep that in mind. Okay, so here this is important. Equivalent resistance R equivalent is less than the smallest resistance in the parallel circuit. So this is the second important thing that you are going to need to solve this problem. So in that regard, you should be able to figure out the resistance. Here it's the same resistance, like in both cases you have the same resistance, and the equivalent resistance you should directly know that's 5 ohms, right? Because you can multiply these two and divide by, multiplication is 100. 100 divided by 10 plus 10 is 20. That means 5 ohms. The equivalent resistance here is 5 ohms. Here, if you apply this fact, you will see that the equivalent resistance is less than 5. So this equivalent resistance over here is less than 5. Here it's 5, this is less than 5. Then how about these cases? Do we know that this, for example, this the equivalent resistance for this circuit, is it larger than the equivalent resistance here or smaller? How about these B and C, the equivalent resistance for these circuits, are they larger or smaller than 5 ohms? So that's another important thing that we need to understand, what happens in a situation like this. So let's try to look into that. So here you can see the same set of 5 circuits. Now let me consider this resistor as R1 and this resistor as R2. You can see R1 remains the same at 10 ohms, but R2, when I go from A, B, C, R2 increases. Initially it was 10 ohms, 20 ohms, and then finally it's 30 ohms. You can see the same system here. One resistance is constant at 5 ohms, but the other one increases. So we want to know what happens, like when one resistor in a 2 resistor system, like the 2 resistors are in parallel, what happens if one resistor increases? What happens to the equivalent resistance? So that's the idea behind this analysis. So what I'm going to do is that I'll write down the expression for equivalent resistance. R equivalent, you should now know how to write it very quickly. R1 times R2 divided by R1 plus R2. Okay, now what I'm going to do is I will divide this expression by R2. The numerator and the denominator, I'm going to divide it by R2. So then in the numerator I'll have R1, and here I'll have R1 divided by R2 plus 1. That's the equivalent resistance. Now as I told you, in A, B and C, R2 is increasing. Initially it was 10, then 20, then 30. So let's see what happens to R equivalent when R2 is gradually increased. So R2 is increasing, Okay, and then let's look at this ratio R1 over R2. What happens to this ratio? R1 over R2, if R2 is increasing, then R1 over R2 ratio, that's decreasing. Okay, so that means this numerator, this denominator R1 over R2 plus 1, that entire denominator is also decreasing. Then how about 1 over the denominator? 1 over R1 over R2 plus 1. What do you think will happen to this term? It's going to increase. Okay, as a result, you can see R1 divided by R1, R2 plus 1. This ratio is increasing, and that means, so this is finally, this means R equivalent, right? That's going to increase. So what we have is, when R2 is increasing, we have R equivalent increasing. This is a very important fact. When you have two resistors in parallel, one resistor is increasing. What happens to the equivalent resistance as one resistor is increased? You can see the equivalent resistance increases. So as you know, this equivalent resistance would be 5 ohms. Here it would be larger than 5 ohms. Okay, so you have R equivalent B. This is R equivalent A, and this is R equivalent C. So what you'll have in terms of this resistance, the equivalent resistance, you'll have R equivalent A less than R equivalent B less than R equivalent C. Okay. Now similarly for D and E, we know that this resistance is less than 5 ohms. So R equivalent D is less than 5 ohms. However, this resistance, this equivalent resistance is greater than the equivalent resistance for D. R equivalent D is less than R equivalent E. Okay, so we have these relationships, and then this term is larger than this one. R equivalent E is smaller than R equivalent A. So I'll write down the expressions for the equivalent resistance. So the smallest equivalent resistance is for the D circuit, and then the next one is the E circuit, and the next one is for A, and then we have the B circuit, and the largest equivalent resistance is for the C circuit. So this is the smallest equivalent resistance, and this is the largest equivalent resistance. So you can see this is the increasing order, like in this direction it's increasing. That means the resistance increases. But what we need is the total power dissipation. So if we go back to that question, it says in order of increasing total power dissipation. So that means we should know that total power dissipation, as I told you before, is inversely proportional to the equivalent resistance. Okay, so that means you have the smallest power dissipation starting with the largest equivalent resistance, which is circuit C. So if I write the total power dissipation in the increasing order for these 5 circuits, the smallest is for circuit C, and then for circuit B, then for circuit A, this should be power, so I need to write down the P, A, and then P, E, and then finally P, D. So here this is the smallest power dissipation, smallest total power dissipation, and this is the largest total power dissipation. So this is the order of increasing total power dissipation. Okay, so that's how you do this particular problem. So this is a very good problem for a multiple choice question. Okay, so with that I'll conclude the video. I'll post another video very soon. Thank you.